without further ado, we shall get into it. Good afternoon, everyone, and welcome to Trimble RealWorks production demonstration. Pardon me, my name's Steve Anthony, and we'll be running through the production mode of Trimble RealWorks this afternoon. It'll just be a very brief introduction to RealWorks, which was covered off in our previous sessions, and then we'll jump into it. You'll have to excuse me as well this afternoon. I've got a bit of a frog in the throat, I'm sorry. So Trimble RealWorks is point cloud processing and analysis software for 3D laser scanning professionals. Has automated tools and point cloud specific workflows allow users to import point cloud data from virtually any source, quickly process, analyse and create high quality deliverables, which is what we're going to look at this afternoon. There's 4 basic levels of RealWorks. Pardon me, we have RealWorks Base. Provides a set of tools for basic point cloud registration, navigation and viewing, includes surface creation and editing, volume calculations and ortho photo generation. Pardon me, RealWorks Advanced includes automatic registration for target-based and targetless projects, automated object classification, advanced drawing tools, complete set of surface-to-surface and 3D inspection tools, as well as the ability to publish projects. We then go up to advanced modeler, we add models to your point cloud, deliverables, fitting, extraction, and editing of common shapes. It also includes all the tools available in RealWorks Advanced, and then we go up to Advanced Tank. The storage tank module is a highly specialised module for storage tank calibration and reporting. So they're the 4 basic levels that we have. So we'll jump straight into it and we'll get into our RealWorks. So some of you guys that were with us on the previous sessions will be familiar with this. This is the start page that we get when we launch into RealWorks. It automatically puts us in this registration configuration, which is the stuff that we went through the other day. So today we're going to look at production mode. And some of the stuff we can do in here in the time allotted, we'll just touch on a couple of them and dig a little deeper into some of these different tabs that we have available to us here. So I'll just open up project here. Sorry. And right. In here, I'm just going to, delete these. So in this home tab here, we import our data obviously. If we're moving across from left to right, we have this Open Scan Explorer, which is a plugin for Trimble RealWorks, which is really very handy for extracting some of the deliverables that we've been talking about. So when we open Scan Explorer, it takes us into this kind of station view with an image overlaid on our point cloud. And we can skip between stations, familiar type workflow that we've seen in TBC as well. So there's a few differences in here though. So these are all our stations. In here we can create entities into, line work and models and the like into RealWorks. We can also create them into SketchUp. The rest of these tools are more for extracting data from the cloud, but these top 2 we'll just have a quick look at today. So in RealWorks firstly, we have a tool, all these different tools available to us to extract different objects. One of them that we have in here is this edge extraction. So if I select that and then I simply pull a polygon around the edge of a particular room in this case, and I create, it'll automatically create the line work for me. So sorry, if I jump back into RealWorks, and the line work's automatically put back into here, into RealWorks for you. So I can extract the roof and the floor and all the rest of it and export those, or export that line work into CAD and, you know, tidy it up accordingly, extending and trimming all my line work that way. So back into Scan Explorer, we can do some others here if we wanted to. We can just and so on and so forth. Okay, we have some other tools available here for creating points and also just basic polyline drawing tools. We also have some basic modeling tools in here, which I'll have a bit more of a look at when we go over into the SketchUp entities mode. So I'll jump over into there now. So if I click on this SketchUp icon here, you just have to bear with me because the way this is presenting on my screen, I haven't got all my icons available to me. So I should have SketchUp. There it is. And so it'll take us into SketchUp. This is the new scan extension tools up the top here, which I haven't had much of an opportunity to play with as yet, but I'll come back into here. So if we wanted to extract features into SketchUp, so one of the nice tools in here that wasn't in the RealWorks workflow is this one here, walls using 2 face points. So we can pretty quickly model this warehouse using this tool, do a basic modeling. So if I select the floor and the roof and then simply click around the walls of the building, I can't see that wall, so I'll just have to step up to station 3 and keep going. And I'll come back to station 2, it's a bit easier to see. And keep going like so. Okay, so if I create on that now, and I'll go back to my SketchUp. Okay, we now have our warehouse model without the walls and the floor. There is an option to add them to the model in SketchUp. So if I jump back over into Scan Explorer, we can also model these rooms pretty easily. So this select and extract this box tool here with the polygon option. So I'll just roughly select it around here and create. And then I'll come back to our other training room, which is the one that I'm sitting in talking to you guys right now. And grab that one and create that. So now, if I come back to my SketchUp, my training rooms are modelled as well. Okay, so there's all, and then, you know, onwards and upwards from there with your SketchUp model. So there's all those kind of tools now. Well, they've been around for a while, but they have improved a lot from RealWorks in SketchUp. Okay, so I'll get out of there. So basically, yeah, that's Scan Explorer. There is some other functionality here, as I said, with point extraction and measurements and stuff, but won't take up your time with that today. So we'll close Scan Explorer. The other is back in this Home tab. We looked at Scan Explorer and SketchUp. There's not a lot of other stuff in here. We can publish these projects, so much like your Clarity out of TBC, we can publish these projects out of RealWorks, it's an embedded Scan Explorer, a version of Scan Explorer that opens the data up and customers can take measurements. They can even extract data from the cloud in there as well. So we're going to look at some of these other tools, drawing and surfaces and inspection. I'll close this project and open up this one here. Okay, so this was a data set we were looking at the other day when we were doing the registration stuff. So this data is now registered, georeferenced and all the rest of it. So we'll run through a few of these tools in here. First one I just want to have a look at, or actually I'll just quickly show you this before we jump in there. In the edit tab here, we can rotate and shift our project and a lot of the common type functions. We also have these auto classify tools here, much like you do in Trimble Business Centre with the auto classify regions. We've got the same kind of functions in RealWorks. Probably auto classify outdoor, same kind of thing. It'll split the clouds out into different layers over here in our workspace, and indoor. Okay, so floor, ceiling, walls, etc. And we also have the segmentation and sampling tools, which you'll see me using a little bit over the rest of this presentation in other tools. They're probably the most common functions in there. So we'll jump into surfaces. And in here we want to create a mesh of part of this car park. That's what we're going to do here today. So we hit mesh creation. So a lot of this segmentation and sampling tools, as well as living externally, they live inside a lot of the tools. So you don't have to do all your segmenting and sampling and then go, oh, okay, I'm right now, I'll go and mesh it. You can actually just do it inside the tool, which is nice and handy. So I'll just select part of this point cloud, which is the ramp coming down into the car park. Something like that'll do. Grab what's inside there. And then I'll just basically, because we've got some other tools that make this a bit more automated for us, I'll just grab that, get rid of some of it. Okay, so we're left with people and a leg of a tripod there on the side of the road and a few bits and pieces. So now we've segmented out the point cloud we want to work on. We're going to sample this and tidy it all up and dumb it down basically as well, so we can just have a nice smooth mesh of the road there. So the first sampling I'm going to run is just a ground extraction. Okay, so that'll get rid of a lot of this stuff. So if I run that, okay, you can see it highlights a lot of the little people and whatever else we've got on the road here in red. So we'll keep the ground, but you'll notice that far from perfect. There's still, bits and pieces of people's shoes and whatever on the road, and you see that with car tyres and the like. So in RealWorks, we have this tool called topography-based sampling. What it allows us to do is basically bring down a vertical filter on the surface and highlight, basically set our own algorithm for the ground extraction. When you think about it, is what it's doing. So it'll highlight in red what it's got there. I usually like to take this down until it's just eating into the road surface, and then we've got 5 million points there. If we lose a few of them by sampling, it's not really going to worry us too much. I'd rather get a nice smooth surface here. So that's just starting to eat into the road surface there now. So I'm pretty happy with that. So if I go erase unwanted, and we've now got, like a billiard table type road surface without all the lumps and bumps on it that we had before. And lastly, I guess we're going to do a spatial sampling on it. So we don't need 5 million points, that's for sure. Probably a point every 300 mil will do us. So if we spatially sample that, Okay, so sampled it down for us, released with 1,000 points after all of that. And we hit apply. And we want our mesh thrown down on this in the Z projection, which is right. So if we hit preview mesh, it's done. Okay, so we've got a nice smooth mesh there, no spikes sticking up in the air or anything gnarly like that. So if we hit create, close. Okay, we've now created our mesh on the ramp down into the car park. So just a few other functions that we've got in surfaces to have a look at with the mesh. We've got mesh editing, which I won't go into here. It's basically tidying up your triangles. You can import break lines if need be and rerun the mesh using break lines. And a few other functions in there. We've got over here, next to the surface tab, the slice tools tab, and we can contour this. So if we go from say 10 to 200, yeah, that'll do. 11. Okay, so it's just contoured up the ramp for us, and if I hit create on that, close it, we've now got a folder over here in the bottom left with our polylines at different URLs, okay, which we can export out to CAD, whatever you want to do. So further to that, we have just a profile cross-section tool as well, which is pretty quick and easy. So normally you'd probably import a road center line or some kind of line work to define this, and then it'll just be in this drop-down menu. I'm just going to draw one. And then start and end chainage, cross-section every metre either side. Apply. Preview. So here we have our profile, a long section, chainage 0, and we can step through every metre, checking our cross sections over here on the left, and then a 3D view down the bottom here. Okay, so if everything looks okay there, we can hit create on that. And same kind of deal, we end up with another folder here with our cross sections, with our long section, and all our cross sections at chainage. Okay, so yeah, probably don't need to do too much more in surfaces. That's basically it. While we're in this same data set, I'd just like to, one thing we get asked about a bit is inspection tools, or comparing different surfaces, generating heat maps and generating sections between the maps and all the deliverables there. So so I'm just going to hide, put that back on, and I'm going to hide that. Right. So in here we have this inspection tab to do this. So we have twin surface inspection, surface to model, if you have a model, a design model or something that you can import. What I've done on this particular job, this was a demo that we did, and they had some boards up over in the corner here, and you can see that they've been moved from scan to scan. So they did that so we could show them, how we can report on that basically. So what I've done is I've created a mesh on both of those surfaces, okay? And so we're going to compare them and generate a heat map, etc. If we select those two surfaces, this twin surface inspection tool now becomes enabled. So if I select that, brings us in here. We've got our red is our reference surface and our green is our comparison. So if I want to flick those around, I can just toggle them the other way. And we'll have red as our reference surface. I'll turn off the green so I can define, at the moment it's saying, well, I'll compare the two surfaces in the Z plane, which I clearly don't want. I want my comparisons to be square to my reference surface. So to do that, I can just define a plane on this reference surface. Okay, now everything that I produce will be square to that, or I could have it square to my reference, my comparison surface if that's what I wanted. We're going to create basically a point every 20 mil over that mesh, and we're right to go. So hit preview, and we get this kind of heat map visual here. So with our colour bar down the side here, we've got everything from 33 mil at the top down to 200 mil at the bottom here, and we get the heat map thrown onto our reference surface down the bottom of the screen here. So we can, again, all these we can create this heat map over here. But if we want to dig a bit further into this, rather than just creating a heat map, we go into this map analyzer tool. And what this does is it creates sections through the heat map. So we can export them as cross sections. So what I've done here is I've got a section every 50 millimeters. I've nominated over here on the right, up the reference surface, and you can see every 20 millimeters along that, which was the resolution that I set, it's sampling the spacing between the two, basically, and creating a cross section accordingly. Okay, so I can create those. I can also run them vertically between the two surfaces, and I can step through them here and have a look at where I am, and then once I've got it set up how I want it, just create. I can export them straight out, or I can create them, the cross sections that is, so they live over here, and then export them out. This button here, so this slider up the top, so I can move it along. But if you're, for example, doing monitoring work and you wanted to compare these results over time, you need this slider and therefore these sections to be set at the same position each time. So here I can simply type in the coordinates of where I want my 0, 0 basically to be each time. So I'm comparing apples to apples when I'm bringing in scan data and comparing it. So yeah, that's the inspection map analyzer. So the inspection tools, we also have floor flatness tools, which I won't go into here today due to time constraints basically, but they're pretty straightforward. We put a grid over the floor, we can nominate tolerances, and it'll give us a heat map again, and also a grid showing the differences between the RL that we've chosen and the point on the well, commonly slabs, and we can export a report as well for that. So they're the inspection tools. Am I going time? It's 20 past. Okay, so while I've got this data here, I just want to show you some of the drawing tools. Okay, so we've got okay, so we've got some curve here. So in drawing, with the polyline drawing tool, much like what you guys with what they call smart picking in TBC, we've got the same kind of options here as well. Okay, so we can just select anywhere on the. Okay, and it'll snap to the curve for me, or invert as we call it here, and we can, stuff most of you guys have probably seen before. Okay, So we can create that, so on and so forth. So yeah, those kind of standard drawing tools are in there. What we also have in here, particularly good for curbs, is this easy profile tool. I'll just show you that. So if we had a section of curve, and I'll look at this section here, and we jump into there. So I'm just going to segment out the bit of curve that we want to. So what this tool does is it basically creates multiple strings at the same time based on a profile that will give it for, well, in this case, curve. You can use it for anything, really. So I've got the section of curve I want to string. If I go into this cutting plane, and I'll just cut out part of the curve that I'm going to use to define. You can also, in here, import, design cross sections of curve and the like, and overlay them on the cloud and do it that way. Here I'm going to okay, so it has figured out it's a best cross section kind of solution for me, and I'm going to come in here. I'm going to draw one, but as I said, we can just import and once you've drawn them, or you've drafted them up in CAD or whatever you've done, and you've brought them in here. Well, you only need to do it the once. You don't need to do this every time. Just for the demonstration, I do so. Create. Okay, so now it's plonked that profile down on the curve there for me, and I've told it I want to run this to run so it'll sample the cloud every 300 mil. So if I hit start on that, okay, so this is only a small section of curve, but where it's really handy is like on long runs, obviously. When you get to driveways and rollbacks and things, you've got to stop and restart. So you can see what it's done there. Every 300 mil, it's gone along and fit that profile that I created to the cloud. So if we create on that, close. Now if we come back out here, okay. So yeah, it's the easy profile, and this one next to it, profile matcher, is where you have an existing profile that you want to import and overlay onto your curve and hit go, basically. So yeah, that's all I really wanted to look at in drawing. I think what we'll do is we'll have a quick look at a couple of things in modeling, and then that'll probably do us. So I'm going to close this data set, and just going to open up. Okay, so this was the power station that we scanned up at Lake Macquarie, and we've got the modelling tab here at the top with all these different options available to us. As you can see here, we've got a lot of pipe work and quite a number of beams and all the rest of it. But what we're going to look at here is modelling pipes. There's a few different ways of doing it, but if we just wanted to model a section of pipe, we've got this tool here called Easy Pipe, which is, as the name suggests, is quite easy and straightforward to use. So if I select it and I hit extract on that, I can just select a section of pipe. It will calculate a diameter for me. It doesn't allow you to edit that at this point if you know differently, but you can edit, like after it's done its modelling, you can go in and change the diameter later if you're that worried about it. Pardon me. So once we've extracted that section, if we hit start on that, So it'll model as far as it can until it hits these flanges, obviously, and then we need to tell it to keep going. Okay, so we can select further down the pipe and it will just keep modelling as far as it can find. Okay, round bends, no problem. So in here now we've got a 90. I'll hit, so the next thing we do is we smooth it. It's all the different elements that we've just created, it smooths them. And then if I hit model, it'll automatically fit an elbow in there for me, best fit elbow between those two straights, and create. Close. So now I've got model pipe work. So I can go through and, do whatever I wanted to do in here. There's a lot there, but it has got this auto extract cylinders as well, which works quite well actually, but it processes the full TZF scans, takes a while, but in this scenario, it's probably worthwhile. You get a lot of this pretty much automatically modelled rather than doing it the way I just did it. Whatever you think suits. So just lastly, the other one we get asked a fair bit about, as well as pipe modelling, is beam modelling. So this is a rail yard thing where they bring the carriages in for repairs and stuff out at Auburn. So if we jump into the modelling tab here, I'll select cloud. We've got these Steelworks options. So we're going to model some Steelworks. And firstly, I need to just segment out part of a beam so we can fit a beam cross section to it, and then from there on we can duplicate that to all the other beams. So I'll just select that section of that beam there. Okay, so we've got our beam. So we have H beams and I beams. This is in this set up an H beam. We've got a couple of Steelworks catalogues loaded in here. I know this particular beam lives in, pardon me, in this other catalogue. So what I'm going to do here, and create it. So now, if I jump back into my station view, I've got a partially modelled beam. I just need to select that now and modify geometry so I can drag this to the full, I can only sample part of the beam. So, So we've created our first beam. Now for all these other beams, I had a bit of a cheat before we got on. I measured between these beams and they're basically 8 metres. I've also set this job up on a UCS, so user defined coordinate system. So the y-axis is running, and on a lot of these jobs, it's a smart thing to do because it allows us to duplicate and shift data along the axes, which is a nice, quick, easy way of doing it. So if I come back in here and I select that beam, I'm coming back into the modelling tab and I can duplicate it. And I want to duplicate it along a line. And I want it to be along the y-axis, and I know there's 11 of these beams running down that way, and they're at 8 metres. Okay, it's gone the wrong way, so I'll just invert. So they've now whacked onto all those beams going the correct way, and I can create those. Okay, I've also got two that I want to do the other way. So, okay, and so I can pretty quickly and easily then duplicate these beams along the x-axis, to snap onto these and so on and so forth. And you can it just kind of gets exponentially quicker once you've modelled one beam and then you've modelled a row of beams and then, so on and so forth. Pardon me, you can step through the building pretty quickly and get your basic beam modelling done. So that's the modelling tab. If anyone's got any questions, I'm happy to take them on board. Yeah, we can provide some demo data if you would like to let us know what particular data set out of that lot you were chasing. Yeah, we can certainly provide you with some data. And Tim, are all of these functions available in TBC as well? No, they're not. A lot are in the point cloud module now. One of the main differences, and Ross might be able to chime in a bit here as well, is that we in RealWorks we can generate based on projections with a lot of things. So with the heat map, for example, like you might have seen there, I know you can do surface to surface comparison stuff in TBC, and you can generate heat maps, but I think it's just slightly different processes there. And also with the sampling tools, which are one of the main things I touched on there. So there is a couple of basic sampling tools in TBC. In RealWorks, there's probably about 10 of them. And that one that I showed you, the topography-based sampling, where I removed the last bit of noise off the road surface, that's a bit more of a manual process in TBC as it stands. Okay, well, if nobody's got any other questions, I might leave it at that. I'm contactable on my email if anyone wants to follow up. The gentleman there that was chasing up some demo data, if you'd like to contact us on my email, which I'll just put up on the screen there.
Just add to this while you're doing that, Steve. The difference between the two packages really is RealWorks is to get you that 3D model to essentially go to something like Revit and those sorts of things, whereas TBC is more your 2D outputs for like design and that sort of thing. In TBC, we can't really create 3D models, so it's more that 2D line work that you're trying to get out. And in RealWorks, it's that 3D aspect, but it doesn't have that 2D. It has a little bit of the 2D component to it, but it doesn't do it as well as, say, TBC. So the two packages, while there is a bit of overlap, there is not a full overlap for the function between the two, due to the fact that they've really got two fairly distinct outputs at the end, and that's sort of the way that we want. So if you're wanting 3D models, then go through RealWorks, and if you're wanting 2D design work and that sort of thing, then go through TBC, and that would be the sort of the best way that I would explain the two of those.
Yep. Okay. All right. Thanks, Ross, and thanks everybody for your time this afternoon. Have a good day. Cheers.